It's the theme to I Dream of Jeannie. If you haven't seen that show, get yourself some deja vu and watch it, because Dream of Jeannie's, it was a great show. All right. If you don't know who the genie was and you watch Worst Celebrity Cooks in America, Barbara Eden was the genie, if you ever watched that show on Food Network. All right, so here we go. You guys, believe it or not, can already do this whole page. But let's just make sure. Step 1, we are identifying the dependent and independent variables. Now, I gave you a shortcut to that, didn't I? I said the dependent variables are the range, and they live on the y-axis, right? And the independent variable is the domain, and it lives on the x-axis, right? But then I also warned you that sometimes to display a graph, people turn it sideways, yes? So you don't want to go by that, what I told you, as a hard and fast rule. Do you understand what I'm saying? It's a guideline. If you're going to use it, you still got to know what independent and dependent means so you can make sure you're right. So if you follow my rule and the independent variable is on the x-axis, then the independent variable here, the IV would be what? Time. Now let's stop and think about that for a second. Does that make sense? Are all of us scuba diving right now? Are we? Is time passing for us? So is time independent of whatever we are doing at any given moment? Yes. So time is almost always your independent variable. Because right now there are indeed people scuba diving in the world, aren't there? And they are underwater for a certain amount of minutes, aren't they? We are not scuba diving. Sadly, we are doing math. Do any of you indeed scuba dive by any chance? Have you scuba dived? I have gone only in a swimming pool, which was pretty damn cool just in a swimming pool to be sitting on the bottom and breathing. The hardest thing for me, I don't know about you if you've gone scuba diving, is remembering to breathe. Because if you don't, you get screwed up. So I'm sitting on the bottom of the pool and the instructor's looking at me. And I'm like, because there's no bubbles, because I wasn't breathing, because I'm on the bottom of a pool. You can't breathe on the bottom of a pool. And then you realize, oh yeah. It's pretty cool. If you can, and you want something to do, and you got 50 extra bucks, that's about what it costs to take a lesson in a swimming pool. Nothing else is, you don't get anything out of it except, holy crap, this is neat. I should pay 250 bucks and actually learn how to scuba dive. I haven't yet. But I plan to soon, once I kick the kids to the curb. Just kidding. My daughter can live with me forever. Once I kick my son to the curb. Just kidding. Okay, so the independent variable is indeed time. Why? Because time is passing for everybody, no matter what they are doing. It is independent of your activity. Understand? So that must mean, in this case, that my dependent variable is my depth. Everybody cool? And that is the end of the math for this whole graph. The rest of it, you have to interpret the graph. So let's have a look at this. How many minutes did the dive last? How long were they underwater? 30 minutes. How do you know that? I return to the surface, a depth of 0, right? I return to 0 meters of depth at 30 minutes. Now, guys, this is something that causes kids trouble. You want your graph to look like the real world. Do you understand what I am saying? If I scuba dive, where do I go from the boat? I go down. Where did this graph go? Up. And to the right for time, yes. You guys get bothered by graphs. You forget that this is not a drawing of my scuba dive, is it? This is a drawing of how deep I was in the ocean over a period of time. Do you understand the difference? When I dove into the ocean, I probably swam around in a bunch of circles. I might have swum up beside some giant whale, right? None of that is shown on the graph. The graph is not an illustration of what you are doing. Do you understand? It is a representation of the data that you are counting. Got it? Okay. So, when did she stop her descent? So at what points on the graph was she not swimming any deeper? Have a look at the graph and figure it out. This time right here. Oops, that's a stupid way to do it. Let's get out my good friend the white pen. Here to here, you can see her depth is not increasing, is it? So that must mean from when to when? 4 minutes to 8 minutes, she's chilling out. Maybe she found Dory. Come on! That was good! Pissed me off. I don't even know why I tried. Stop telling jokes. Just sit here and do math. Does she stop again? When? From 20 to, not 20, from 10 to 14. Now, what then happens at 14 minutes? She goes straight back to the surface, right? Even though the line is going down, she is swimming up. Do you understand that? I will give you questions on your test that you will show me that you do not understand that. I will fool with you. I hope that I catch none of you. All right? Everybody is good with that? Now, so since we are looking at time, we must have been looking on our domain. Right? Now, what am I looking for here? Depth. So where am I looking? On my range. What is the greatest depth she achieved? 20 meters. And how long did she hang out down there? How long? 4 minutes. All of you can read a graph. Good. Now, tell me the domain and range of this graph. Stop for a second. Think. Can I do it in set notation? Can I do it in interval notation? Yes, both of them are going to be acceptable. Of course, I'm going to do both. You are going to choose whichever one you are more comfortable with, or you're going to write both of them down. Domain is all of my what? X's or Y's? X's, which in this case is what? Time. So what is my lowest value for time? 0. What is always your lowest value for time? Y. What? I'm sorry, Sammy. Okay. Pardon me? The least amount of time you can get. Why? Does negative time exist? No. We do not have a DeLorean that can go 55 miles an hour and is powered by plutonium. Time doesn't get negative. Can time go backwards? Would this line ever turn around and go that way? Why? Because time can't go backwards. Ever. Because we don't have a DeLorean that can go 55 miles an hour that is powered by plutonium. You do all get that joke, right? Right? The DeLorean, flux capacitor, Back to the Future. Anyone?
Yeah.
Michael J. Fox, Christopher Lloyd, meets his mom, she hits on him, thinks his name's Calvin Klein because it's written in his underwear. Very uncomfortable scene in 1985 when I was 10 years old when that movie came out.
Wait, Back to the Future?
Yes. Yes, Back to the Future.
Wait, isn't like 500 Back to the Future?
No, there's 3. There's Back to the Future, there's Back to the Future 2, and there's Back to the Future 3. In Back to the Future 1, they go to 1955. In Back to the Future 2, they go to 2015, and then back to 1955. Which was funny because, of course, 2015 in Back to the Future 2 had hoverboards and all kinds of neat stuff. And what do we have? Nothing. Because we suck. Because in 1985, they thought maybe we'll learn something in 30 years. Turns out we didn't. We're still a bunch of idiots like they were in 1985.
Isn't that when Brendan said like jumps at the car by?
The lightning bolt, that's the first one. In Back to the Future 3, they go back to 1885 to the Old West. And at one point, the DeLorean is a stagecoach. And they got horses pulling it. It's wicked awesome. It's actually the worst of the 3, but it's still wicked awesome. That's like saying, I've got a really bad piece of pizza. It's still awesome. Even 7-Eleven pizza is better than no pizza at all.
No.
Yes, it is. The only pizza that is completely inedible, as you all well know, is Little Caesars. No.
I hate
You're wrong. You're entitled to your opinion, even though it is wrong. Little Caesars doesn't deserve to be called pizza.
7-Eleven pizza is nasty.
I agree with you 100%, but I do not feel it is as disgusting as Little Caesars. Now,
Little Caesars
so
is good.
our domain is 0. Is there indeed a point where I equal 0 time? Yes, when I start. So now, what goes here? X? X would go there if this was a graph. This is not a graph, is it? I lie. This is not a Cartesian plane. So what should go there? It can't be X because X is something. What is X? On this graph, what is the X time? So we have to put time there. And what is the greatest time we have? 30. How would I write that in interval notation? Square bracket, 0, comma, 30, square bracket. Cool? And what is the range? What is the lowest depth we achieve? It's a trick, isn't it? 20 is the lowest depth we achieve, but how do I graph that? Isn't that positive 20? It's negative to the surface, but the domain and range are gotten from the graph. The graph is not real life. The graph is a representation. So what should our lowest range be? 0 still. And this is depth. And what's my highest? 20. And how would I write that? 0, 20. Is everybody good with that? Please understand, you are interpreting a graph. You are not describing real life. Do you understand the difference? Excellent. Let us carry on, Cabbages. I have a new graph. Shows the volume of water in a watering can over time. Write a scenario that explains that. So now you are going to use this graph to put it into real life. So what are you doing? Now, you have to look at this graph. Are you doing the same thing the whole time? No. There are definitely how many parts to this graph? 3. So how many parts must there be to your explanation? 3. There is part 1, part 2, and part 3. Go! Write out what is happening there. And remember, this is not English class. You get no bonus points for a really fun description. But also remember, it's me. Do you get bonus points for a fun description? Figure it out. Jeopardy theme. Which is really, I'm a little teapot. Would anybody like to tell me what is happening in section 1? Antonio. Right. So in section 1, I am filling the watering can for how long? 30 seconds. Yes? Does everyone agree? Was the watering can empty? No, it had some water in it. I am filling it all the way up. What is happening in section 2? There you go. I'm walking over to my sunbathing sister who's lying on her tummy listening to music. And what am I going to do when I get to 3? I'm going to dump it on her. Did I do this? Am I a good big brother? She loved it. Have I seen this done on a beach? Yes. Were the ladies lying on their tummies? Yes. Did they have their bikini straps undone? Yes. When the guy dumped cold ocean water on their back, what did they do? Jumped up, leaving what on the ground? Their bikini tops. I was 9. It was the greatest day of my life. My sister was not with us, so my sister did not know that that was an option. So she foolishly was sunbathing in the front of the... She did not have her bikini off, but she was lying in the front of the house. Because, of course, had she been lying on the front of the house with the bikini or bikini top off, even on her tummy, my dad, of course, would have killed her, as I plan to do when I catch my daughter sunbathing with her bikini top undone. Don't you know your brother could run out here and dump water on you? Because, of course, my son has heard the story. Everybody good? Of course, most of you probably wrote walking over to your plants and watering your plants. Boring, but that's okay. It's still right. Would I take any marks away? Of course not. Would you get a giant happy face if you came up with a crazy-ass plan? I like a good caper. All right. Now, moving it along. Draw an accurate distance versus time graph to show this. So, remember I told you graphs need scales, they need titles, they need all that stuff. Where is distance going to go? On the y-axis. Why? Because you said time is always the independent variable. Sure. Now, you need to draw this, and I'm going to call your attention to a certain word that is going to be very important very soon. Distance. Draw this graph. Draw it in pencil in case you screw it up. If you don't have a pencil, then I would recommend cutting this graph in half and doing your version here, and then over here, if yours is wrong, you would draw the real one. Okay? Go. You can talk to your friend. You can talk to your neighbor if your neighbor isn't your friend. You can not talk to anybody. I don't care. But I do hope to see 30 sketched graphs. Whatever you need. In the first 2 hours of his trip, Jack leaves home and drives 140 kilometers at a constant speed. What does that mean? Does he stop? No. Does he turn back? No. Does he go super fast then slow, then super fast then slow? No. So what does the first section of this graph look like? A straight line. Going where? Up and right, because time marches on, yes? So the first part of the graph must go like this. Until when? 2 hours and 140K. Agreed? Is everybody cool with that? So that is A. Yeah? A. Section B. Visits grandma for 1 hour. What stays the same? The distance stays the same. Why? Because he's not going anywhere. He's sitting at grandma's house. Hi, Grandma. Hi, Jackie. I'm a little broke right now, Grandma. Can you float me alone? Of course. Right? So there, for 1 hour, it's a horizontal line. That is B. C we will draw in blue. Jack drives 50 kilometers back towards home, but then stops 30 minutes for supper. Now here is where you're going to screw up. Where does the line... Where did you draw your line? Somebody describe your next section. Did you go... First of all, do you go left or right? Right. Why? Because you cannot go back in time, no matter how cool your DeLorean is. So you have to go to the right. Now, Did your line go up and to the right or down and to the right? How many people went down and to the right? 5. How many people went up and to the right? 1, 2. It is indeed up and to the right. Why? Don't fix it yet. Think about why. Antonio, why? You're not looking at your location. You are telling me distance. Your car is still traveling a distance. Do you understand me? Here is what I mean. I'm at my starting point right now, yes? Everyone agree? Now, if you watch me, look at me right now. Everybody watching? How many steps did I take? 3 there, 3 back. 6 steps, yes? Now, close your eyes. None of you are going to. Pretend your eyes are closed. Now open them, and I'm back in the same spot. If I wasn't wearing shoes, if I was wearing ninja shoes and you couldn't hear me take steps, would you know that I had moved? No. So the second one is what we call displacement. I moved 3 steps away, which are positive 3 steps, and then I moved 3 steps back to my origin, which is negative 3 steps. What's positive 3 minus 3? 0. So on a displacement graph, I have gone nowhere. The graph would look like this. Up 3, down 3, and I'd be back at 0. Understand? But on a distance graph, I took 6 steps, so the graph keeps going up. Everybody with me? So now that you know that very first graph we did of the scuba diver, is that distance or displacement? That is displacement because she came back to her original spot. Okay? So, you got to watch out for that. On a distance graph, we would go up and time would go on for 50K, yes? So this would be 190. Yeah. I'll get to that in a sec. How have I drawn that? I mean, it's a little shaky because I'm old, but how have I drawn that? As a constant line, yes? Do we have any information as to how he drove that? No. So Antonio's just asked, well, how do we know how to draw that line? You don't know, so you give your best guess, right? You just draw it. You could put some zigzags, I don't care. But what are you not allowed to do? Go back. Or, on a distance graph, down. You cannot go back, you cannot go down on a distance graph. That is part C. How long does he stay there for supper? 30 minutes. So we have to have a flat line for 30 minutes, yes? And that covers section C. And then he returns home taking 2 more hours. Right? So home is going to take me back to 280, isn't it? Oh, I should change colors there. Sorry, green. Because to get to Grandma's was 140. That's halfway. Turn around, come home, 280. And I got to go up for how long? 2 more hours. Everybody cool? That is D. Does everybody understand? And that is a distance graph. Were it a displacement graph, then what would be the only thing that changed? Right here, I would turn around and go down because I was going back towards home, stop for a while, and then finish going home. That is a displacement graph. That is a distance graph. Do you all understand? Displacement is the amount of space you have traveled from your starting point. It is what we call a vector because you have a magnitude and a direction. All right? Whereas distance is only a magnitude. Think of it in your car. Your car has an odometer, yes? If you drive from your house to Disneyland and home, and aliens watched you, flew over Earth and saw your car at home on Monday, flew over Earth 2 weeks later and saw your car at home on Monday, could they know that you had driven anywhere? No. But your car has an odometer, yes? And your car measured that drive to Disneyland and the drive home. Understand? The odometer measures a magnitude, right? The time that you spent. Now, something you need to know about odometers, Ferris Bueller, running it backwards really doesn't work. That's true. It works on some old cars, but not very many. So don't do that. And also don't kick the car and have it roll off and fall into the woods. That's bad. If you haven't seen Ferris Bueller, none of that made any sense to you. And if you haven't seen Ferris Bueller, I cry for you. I am sad because it is such a phenomenal movie. How many people have seen Ferris Bueller? You know, there is a school of thought that thinks that Ferris Bueller doesn't exist in that movie, that Ferris Bueller is a figment of Cameron's imagination, meaning Ferris is what Cameron wishes he could be, kind of like Fight Club. I'm sorry, if you haven't seen Fight Club, that's a bit of a spoiler. I usually get mad about that. But if you haven't seen Fight Club, again, great movie. Everybody okay with this? Okay, remember, there's a bunch of blank space here. Let's remember. Distance is total travel. Both there and back. Just like The Hobbit, there and back again. It is a magnitude. Meaning we don't care about direction. Displacement is a vector. Meaning we have a magnitude, which I just defined right there, and direction. Okay? So math and physics people have agreed on a couple of things. North, right, east, up are all positive. Okay? Now you guys are smart kids. That means south, left, west, down. Oh, I forgot one. Backwards are all negative. I got to add forward over here. Okay? So, for me, if I displace 3 steps in the positive direction, am I going towards the fridge or towards the door? For me. You got a 50-50 shot, guys. It's written on the board right behind me. For me, where am I going? 3 steps to the fridge or 3 steps to the door? To the door, because that's right for me. Understand? Positive 3 steps. 1, 2, 3. For you guys, what was that? Negative 3 steps, because I went left. Got it? So I have traveled 3 on distance, right? Does the distance get a positive or a negative? No, because I've just gone 3 steps. Doesn't matter. No direction. I'll be right with you, Antonio. On displacement, I have gone, for me, +3. Got it? Now, if I go -2, 1, 2, am I back to where I started? No. What is my displacement? +1, because for me, I'm 1 step to the right of where I started. What is my distance? 5, because I went 3 and 2. Got it? Antonio, what's your question? So what do you mean? Direction. So if I'm moving in a northerly direction, on a graph we would make that positive. Is that what you're asking?
I'm just confused because after north is right, but on a
They're not saying north is the direction.
No. North.
That was asking.
No. Oh, sorry. North or right or up. Okay.
Just want to get the Hansel and Gretel field trip students to assemble now downstairs.
Any of you Hansel and Greteling? Okay. Good, because then you get eaten by a witch. Which really happened in the real story. The witch wins and eats Hansel and Gretel. The superhero woodcutter doesn't save them because fairy tales were designed to scare children to stay at home and not do stupid stuff like wander through the woods like idiots. But now, because everybody is a wuss now, but go ahead and do something stupid because the superhero axe woodcutter guy is going to come and save you. No! Just like Red Riding Hood got eaten by the wolf. Okay? No one's coming to save you. The world is a violent, scary place. I'm just kidding. I'll be there to save you guys, I promise. All right. So your job, because it's 10:48, I'm going to get you guys to try and figure out the rest of these 3 until page 135. I lie. Worst liar. 133. That's your job tonight. Okay? Over the next 3 days that you should be in school, Thursday, Friday, and Monday, you want to make sure that you have had a look at page 281, page 295, and the worksheet that I'm giving you tomorrow. Okay? Everybody good? Great. Now, I know that you are going to want to know if you did these right before you do any more work. So here's what I'm going to do. I'm going to do 4, 5, 6, 7, and 8. I'm going to continue to do that on this video, and I'm going to post it tonight. So you can go back and check on 4, 5, 6, 7, 8 and make sure you're doing it right before you go to your textbooks. Okay? Okay. Abresia. Of course. Okay. There's the bell. See you guys. All right. So remember, you can watch the video. I'm just finishing it up right now. So she starts at 0, and in 2 seconds, she's at top speed. Hey.
Are you the person in charge for the trip next year?
No.
No. That.
R301, not A301. Miss Sanger. A. Sorry, so starts and accelerates in very little time because as you can see, she gets up to a top speed in very little time, so it has to be really steep. Block B, she stays, what? No? Your teacher may be taking you in Block C to the fine arts performance. Maybe. Until 14 seconds. And then in C, she slows down quickly. Yes.
I wanted to say that I'm sorry for missing a few days, but I have been keeping up with the video.
As long as you're keeping up, that is fine with me. You are a young adult. You can make that decision, and I will not stop you. Okay.
Those absences have also been disclosed.
Okay. No problem. Mr. Lang, I'm seeing you for your polynomials test, yes? Okay, we are doing height versus time. Now this one causes trouble because it is a child on a swing, and a great many of you want to draw this because that is what a child on a swing does, goes back and forth. But of course that has time going that way, which is impossible. So that won't do. Time, height. Now, on a swing, would you start at 0 height? No, because your swing is a little bit off the ground. Then as time goes on, you go up to a maximum height, then down back to your minimum height, and then you start going backwards, but your height is going back up. Because height is a magnitude, just like distance. Distance versus time for a runner completing a 400-meter race. So, time, distance, I start at 0, and I start running. I probably run pretty fast at the beginning. So I get up to the speed I want to run in a pretty short time. Then I'm going to cover some more distance at a slower slope because I'm not going to be going as fast. And then at the end, I'm going to have a finishing sprint. So I'm going to be nice and steep again to get to a distance of 400 and a time of whatever it may be. Whatever, 1 minute. Now, this is tougher because it's displacement around a track. So first of all, I got to think to myself, well, the track looks like this. I start here and I finish here. So as I leave the track, I'm getting further and further away. But then what happens when I turn this corner? I am actually getting closer to home. Then I get further away again, and then I get closer to home. So the graph has to go away towards, way towards, away towards, and so on. What is the only thing I can't do? I cannot go back in time. And finally, position versus time. Is position displacement or distance? Well, it's a position, so it is a displacement. So it must be a vector. So here we go. Time down here and position here. So you got to do this for you. So for me, I leave home and I drive through my neighborhood away from home slowly, so it's not very deep. Now, of course, I'm driving, so stop sign, crap like that, right? And then I hit the highway, in which time I cover a lot of distance in a very short time at more or less a constant speed, right? And then I go, then I'm back in the city, so I slow down till I get to school. Okay? Now, for me, never on that trip do I turn back and go home. So this looks like a distance graph. But indeed it isn't, because if I ever forgot, I would go back home. Like if my wife were to call me right here and say she forgot her car keys, then I would have to turn around, go home at a constant speed, do all this crap again, hit 0, then take off here again, then super fast to school because I'm late, and then this. Okay? This is if I forgot my wallet or something like that. Okay? And that's it.